Right, is this all on? Can you hear me? Good. Good morning, ladies and gentlemen. It falls to me to welcome you to the 42nd conference here at Keele. I hope you all had a good evening last night and everybody seemed to enjoy the race night. There's some good sessions today, so I hope you're all going to enjoy those too and take full part in those. Also the housekeeping questions, I just need to go through the housekeeping items. If there's a fire alarm, there is no planned fire alarm today, so if we do hear the fire alarm, we need to evacuate the building, and there will be fire stewards on hand should that happen. A senior fire steward will direct us to our fire safety point, so please follow, should we get an alarm, please follow the steward's directions. Toilets are located outside in the Chancellor's building. Hopefully many of you have found where those are. If you haven't put a parking permit on your car, please make sure you do so at the first opportunity. The conference team have asked, please can you hand back your feedback forms at the end. It's going to be invaluable for us as a conference team and also as an association going forward, and also to remind you to complete the quiz and take full advantage to visit many of, or if not all of our exhibitors and sponsors today, because as usual they are the lifeblood of this conference. It's going to be brief, so I hope you enjoy the rest of the day. And without further ado, I'd like to introduce Professor Nick Foskett for his piece. Thank you.
Thank you very much, Darren, for the introduction. And can I just start the conference by saying a huge welcome to you, to both to the event and to Keele University. We're always delighted to host conferences of this sort, to bring senior professionals from the sector together to obviously consider matters of mutual concern. And in preparation for your visit, in order to make you feel at home, we've organised some major engineering works on the campus, which you're very welcome to go and have a look at various stages, and I'm sure you'll pass views and comments on them. Keele, for many of you, this will be your first visit to Keele, maybe your first visit to this part of the UK. And I hope that you, in addition to enjoying the conference, you enjoy your time actually here at Keele. Keele is a very distinctive university, I think. We are a campus-based university. Other than the nursing provision, which is down in the city, everything goes on here on the Keele campus. And we do make claims, I'm assured, that this is the largest university campus in the UK. Although next week we have UUK here with all the Vice-Chancellors, and that's not a claim I'm going to make in front of all the other Vice-Chancellors, because I'm sure somebody will challenge me on it. But we believe this is the largest campus. And if you have chance to wander around, you'll see that in addition to the built area at the heart of the campus, there are very extensive grounds with woodlands and lakes and parkland and so on. It's a very attractive place to be. So I hope you'll enjoy just sampling Keele as a place to be, and do take advantage of going and having a look around Keele Hall, for example, the historic building at the heart of the campus. Keele was established as a university just after the Second World War. In fact, it was the first post-war university. And it was a bit of an educational experiment in that it was established to provide a different sort of university education in contrast to that provided by the traditional universities which existed at that time. And the initial summary phrase which was used to try and capture the character of Keele was about learning together in the company of friends. And I think that very much captures the essence of what Keele is about, because it's a very sort of friendly community. When I'm asked to talk about Keele to various audiences, I always say that there are 3 or 4 very distinctive characteristics of Keele. The first one, which I would say, wouldn't I, as Vice-Chancellor, is the quality of what we do. We believe that, as both in terms of our teaching and our research, we are certainly a very high-quality university. We rank within the sort of top 25% of UK universities, and especially in terms of teaching, we rank very highly, and in terms of research in our specialist areas, we rank very highly. So we make a strong claim to quality. The second distinctive feature of Keele I always talk about is our size and community, we're just under 10,000 students strong, which I suppose makes us a little bit less than average size for UK universities. But it provides a great sense of community being that size on this campus. And we know that both our current students and our alumni and our members of staff always talk very warmly about the sense of community here and the sense of belonging. And it was evidence for us a year or so ago when, like every other university, we hold an annual telethon where we get some of our students to telephone former members, former alumni, to try and persuade them to contribute to the university. That's organised for us by an external consultant. And the consultant said that by all their indicators, the affinity which Keele alumni showed for their university was third only in the UK to Oxford and Cambridge. So that shows something of the sense of community that people feel here. The third characteristic which I was talking about with Keele is the campus and the physical facilities we have. And that underlies very much our commitment to sustainability, and I'll say a little bit more about that in a moment. The theme of your conference this week is engineering a low-carbon estate. And I think that's a particularly appropriate theme, not just for the current times, when obviously looking at carbon reduction is very important to all institutions, especially universities. But it's also very appropriate that's the theme when you've come to Keele, when sustainability and carbon reduction is such an important issue for us here. I know that university engineers are at the forefront in their institutions for leading the drive towards sustainability and reducing carbon output and so on. And I know that much of the debate this week will be about ways of improving that and reducing carbon output by 80% of 1990 levels by 2050. So that's an important part, an important theme. As Vice-Chancellor, I'm very conscious of the range of pressures that all universities face, funding pressures, political change, social change, and so on. And in that context, it can be quite challenging, I think, for universities to retain that focus on critical issues such as sustainability. And I'm very keen to explore ways in which universities can maintain that commitment to low carbon futures alongside all of the other financial and social and political pressures that they face. I think it's important not just because it's good for the business for us to spend less on energy and to reduce our carbon footprint, but I actually think the universities have a significant role in society to play in terms of representing positive aspects of change and being beacons of leadership as far as those sorts of social and operational changes are concerned. And I certainly hope that in future years, future generations of senior leaders of universities will take very seriously that obligation to lead by example through their organisations for the future around carbon and energy usage. At Keele, we've taken that very seriously. We revised our strategic plan a couple of years ago, and we have written into our strategic plan, right at the heart of the plan, our commitment to environment and sustainability. It is one of the highest level 6 commitments alongside excellence in teaching and excellence in research and a couple of others. The commitment to sustainability is there at that highest level of our strategic aims. And in order to support that, we ensure that sustainability is written into the detailed plans of every bit of our institution. And we expect academic schools and research institutes and professional directorates to engage in all of the processes to support our commitment to sustainability. One of our senior members of staff, one of our Pro-Vice Chancellors, has a brief for sustainability and environment. And our Director of Estates, who's with us today, Phil Butters, also leads very strongly on that particular theme from an engineering perspective. We try to build in sustainability and environment at the grassroots with the students. As from this year, every single student here will have part of their curriculum where they are exposed to thinking and ideas about sustainability and environment for the future. And we're also very strong on research in the field of environmental sustainability, but we think we need to walk the walk too. So we are very clear that from an operational point of view, we need to make sure the university is committed to energy efficiency, reduction in energy use, reduction in carbon footprint, and so on. I think we made good progress in that. We have as an ambition, perhaps that's a little more optimistic than a target, but we have as an ambition to be carbon neutral by 2020 and to be self-sustainable in energy from our own sources on the campus by 2020. Those will be big asks, but they're certainly something we're seeking to do. And I hope that as part of your conference this week, you'll have a chance to talk to Keele colleagues about the strategies and the ways that we're seeking to achieve that. One of the physical demonstrations of our commitment to all of this is the new Sustainability Hub. And if you get a few minutes within the programme over the next day or two, do walk up to our Sustainability Hub, which is close to the main entrance to the university. It is the old estate farmhouse, which we've converted into a building to bring together the university, local community, local business, to share expertise and ideas around sustainability and environment. And it's an impressive building in itself, but the technologies that operate within it are also very impressive in terms of what they contribute around sustainability and energy reduction. So do go and have a wander up there. In addition to all the impressive facilities, you always also go and have a look at the pig pens which are up there, which have been converted into a very intriguing use. So, just to conclude, very much want you to enjoy your time here. I know you'll get a lot out of it as a professional conference, but I hope you'll go away at the end with a very positive view of Keele as a place, and Keele as a university which is seeking to make a big difference in terms of the key themes of this conference around carbon reduction. So have a good week, and I hope the conference goes very well.
Good morning, ladies and gentlemen. I've got honor and privilege to present the first session, which is going to be carried out by Mr. Dan Goodreid. Dan is a director from Arup, who has got considerable amount of experience in project management, local government, and wider field, especially in higher education. Dan will be presenting his paper on building information management system. It is quite an interesting subject, intriguing, and I'm sure it'll keep you entertained. Thank you, Dan.
Well, good morning, everyone, and thank you very much for giving me the opportunity to talk to you today. What Fred didn't say in his introduction, thank you, Fred, was that I've actually worked with Fred probably now for about, well over 20 years with his university, and it's been a great honour and privilege over that time. I'm going to talk to you today about building information modelling. Now, I always like to start with a bit of a quick poll. I sometimes ask people to close their eyes because there's a level of embarrassment associated with some of these questions. Don't worry too much, but could you raise your hand if you've heard of BIM as a term in the industry? Okay, so that's pretty much comprehensively everyone, and should be no surprise. Could you keep your hand raised if you feel you have a good appreciation of what BIM is? Very, very much fewer people. And again, could you keep your hand raised if you feel BIM is currently impacting on your day-to-day activity and work? Virtually no one. Now that's really interesting, isn't it? Because the government have mandated that on all government-funded projects, BIM will feature as a standard as of 2016. And that undoubtedly has allied to it through the UK Government Construction Strategy a whole package of other measures to improve how we work as a construction industry. And that will impact on the field of education as much as anything, probably more so than many other areas. Now, the problem with BIM is it's a much used term. A lot of people are suffering with what you might call BIM fatigue. We're a bit bored of it. It's in the press all the time. But you need to be very careful because it's so well used. And we could boast at Arup that we've been working in BIM environments for probably 15 years. But you need to be equipped to ask the question and scratch beneath the surface of, well, what actually have you done in this field? What is the reality of what's being done with projects, and what maybe is a bit of a myth, a bit of a realistic view of the future, because it's very hard to tell the difference these days. So hopefully this presentation will provide you with some of the answers, some of the questions that perhaps you can ask. And I've littered this presentation with examples from a project we are doing with Fred and the Birmingham City University team, where I have to say, because of their commitment to doing things differently and in new and innovative ways, right from day one of this project, it has had a great influence and hopefully can be seen as very much a force for good on that project. So just briefly, let's have a look at the term BIM, Building Information Modelling or Management. What is BIM? Perhaps just to start, dispel some of the myths. The term building is in there. It isn't just about buildings per se. There are lots of examples where BIM techniques or database techniques can be applied to a whole range of projects, and here are just some of them. On the Crossrail project, where we've been very heavily involved, we've used BIM techniques, database techniques, to retain and make accessible all the data of all the buildings that new underground line goes under. Now you can imagine that's a massive, massive amount of data which has to be managed in a structured way to be useful. We can also do things such as take the technology beyond to underground, and you can see those images on the left-hand side there. Look at coordination of underground services. It looks at foundations. Those sort of purple colours show you different underlying strata under the site. So it's not just about buildings. Well, is it just about design? Again, not really. I think design is one of the most active areas at the moment, but undoubtedly it has an impact on construction and really, really must have an impact on how we operate facilities. And I guess it's that final leap at the moment that perhaps we're struggling to make, and for that we need your help. So BIM essentially is about modelling. It's about creating what you might call a virtual asset of the building that takes account of all facets: architecture, services, structure, civil engineering, and you could add a whole host of other things: costing information, programming information, construction FM, etc., and on and on. And that virtual asset needs to be maintained, kept up to date, so that it's useful for the whole life of the building, right through to refurbishment, extension, and eventually demolition. So BIM really is a descriptive term, and it's all to do with the process, okay? That continuous process from design, through construction, through to operation, to end-of-life activity. And it's not just about 3D CAD. Just to make that absolutely clear, because a lot of people believe that's what BIM is. It isn't. It's much, much more than that. So I said the UK government strategy addresses how we should do things better in construction, and BIM is actually only quite a small part of that, but I see it as a very crucial catalyst to changing the industry. Just use this as a bit of an example. We have a number of phases of a project, through the initial concept, through design, construction, operation, as I've said. And our current processes, or rather our old established processes, Throughout that process, you get a drop-off of data at each stage. So we have a concept. We take on a design team who tend to start from scratch again. Boom. We go through to construction. The contractor takes the design drawing, says, yes, that helps me appreciate what you want. I now have to produce installation drawings and fabrication drawings. So there's another drop-off of data. And then, of course, coming to operation. And I'm sure this bit is very dear to your hearts. I'm sure on most of your projects you get presented with a really useful suite of about 20 lever arch files of information that you find very easy to use, particularly in an emergency situation when things go wrong on your sites. We have to do better. And this is what BIM is about, to be about creating a life cycle of information. So storing all that information in one place, making sure it's kept up to date, and making sure that it's good and available for anyone to use. It's a chaotic process, construction, and it's not very integrated at the moment. So again, this is perhaps another illustration of what I'm talking about. There are so many parties involved in this design, construction, operational cycle, and they all have different streams. So each of those coloured lines represents a designer or a contractor and the particular bit of the job that they're running, and at the moment they're very separate. So how can it ever come together in one sort of coherent and integrated project? It's very difficult. So what we're trying to do with BIM is to make sure that essentially there's one source of the truth, if you like, about the project. Everyone contributes to that truth, and if someone needs to use data, they take data from that truth, process it, and contribute back to that truth. So in theory, and I don't like making promises in forums like this, you should never really get conflicting data, because it's all drawn and contributes to one model. Really, really important in terms of minimising the opportunity for error, which of course eventually costs money or has other impacts. Now, this term isn't new. Our founder, Arup, came up with the concept of total architecture. And he says that it implies that relevant design decisions have been considered together and have been integrated into a whole project. And judgments on those are made by the whole team, so that they're empowered to properly assess the priorities and what should take precedence. So I hope we agree that this is a good idea. But you have to ask the question, how are we getting on with it? 2016 isn't that far away, when government have mandated that it needs to appear on all projects. Now, I don't know about you, but I feel in my industry, the construction industry, we're still a little bit like this. We're not too concerned. As long as the hole isn't at our end of the boat, we're okay. But of course, the eventual reality is that the boat sinks. And what we're trying to do with BIM at the moment, I believe, is trying to make it fit our old processes, which is fine, and I guess it's kind of inevitable. But we'll only ever make great progress, I believe, when we allow BIM to completely restructure how we undertake projects. Perhaps a bit of an illustration on a slightly confusing diagram. But we have a number of stages of design. And the top line there shows the ideal situation where we have one line of information going through the entire process, right the way from inception through to operation of the building. Anytime you see more than one arrow in a box, that means there's a wastage there. So if we take the second line down, as I said, this addresses the point that currently as a designer, I produce a detailed design drawing, which the contractor then takes, has to rework to deliver what he needs to do the job. And as far as M&E systems are concerned, that cycle costs about 1 to 1.5% of the contract value of the M&E. It's a vast amount of money. If we change the process to eliminate that, we can make that saving and also ensure we have a better quality product. So, what is a virtual asset? Well, it's all based around having an intelligent model. And if I can use the example of a steel structure here, the model on the left-hand side there is a typical stick model that we might use for load takedown. The one in the middle is a virtual representation, a visualization, if you like, of what that actually is. So there's some characteristics of physical size of the beams and the column. Where we need to get to with a fully intelligent model, a BIM, is that all that data associated with that column and beam is in fact embedded in the model. So that if you have an issue with something on that beam, you can simply click on it in the model and it will give you its size, weight, load bearing capacity, paint specification, etc., etc. As I'm an M&E engineer, I have to give a pipe analogy as well. Where we have been is to do dumb 2D stuff on drawings. Where we need to get to is to represent that pipe, in this example, with its proper size, its insulation, its material, its flow rate, all of its design data, so that everyone knows everything about that pipe, just by clicking on it in a model. Think of spaces, okay? You might call them rooms. We can embed with those spaces in the model all of the data that's associated with them, so that you, as facilities managers and engineers, with the model that's handed over to you, knows everything about that space. You know what occupancies it was designed to cater for, what heat loads the designer had in mind when they designed the systems, what its characteristics are in terms of light level, in terms of electrical load, etc., etc., etc. Just by clicking on that space. And similarly for plant. Okay, so any plant item, boiler for example, all of the data associated with that object in the model is embedded with that image. And we can do other things with it as well. On this example you'll see, when we embed data on plant, we make sure we include the maintenance space with it. Okay? So that we can always check that plant and equipment is fully maintainable. So it's about having this continuum of information. So hopefully you can already see that there's going to be a level of data accessible to you guys that probably hasn't been visible before, and hopefully that will be useful to you. And I'll give you some examples in a minute. But what do other industries do? And again, this is drawn from some collaboration we've been doing with Birmingham City University, who do an awful lot of work in the aeronautical industry. They've used BIM processes for years, and they can't really understand why we are so far behind in construction. And I have to say, I agree with them. But in discussion, buildings are very complex things. And we design one, and then we design a different one, and then we design another different one. It's very, very different to, say, designing an aero engine that you can refine and refine and refine and build on as time goes by. So let's not beat ourselves up about that. It's a very, very complex business. So what I wanted to do from this point on is give you some examples from the Birmingham City Centre campus, which, as I said, we've been working on for some years now. It's due for completion towards the start of next year, which is great. And I have to say, it's been a very clear driver from the university from day one that they wanted to push the boundaries of BIM on this project. So are we delivering it now? Some very simple processes first. I'm sure on all of your projects you will have something called a room data sheet, which gives you all the characteristics of a particular room in a development that you need built. Previously we would take that data, we would produce a little drawing of it on a piece of paper, and we would hand it around and get approval for it, and it would eventually get built. Now that link is very clearly established. Through the model, it's all based in one place. It's all accessible. It can't be different. The drawing cannot be different from the room data sheet. And just to illustrate that, I've got a little movie here that shows you how we can very quickly link from the software that we use in terms of BIM, hopefully be able to show you. There we go. So here's a typical room data sheet in Excel. As you can see, it has all the spaces within that particular development and all of their characteristics. Through a simple link that we've developed with the package Revit, which is our BIM platform, We can take that data from an Excel sheet. Everyone has Excel. They can all process data in Excel. And apply those changes directly to the model, which you'll see eventually will produce a drawing of the environmental treatment within that building. So it tells you how every space is comfort cooled, etc. Now, if I just pause the animation there just for a moment. And if any of you are doubting me, I promise this is a realistic, real-time view of operating this model. It's just that I'm a bit nervous about doing that in a live environment like this. This space, the Faculty and Examination Office, has been moved by the architect. It's currently green, which indicates that it's a naturally ventilated space. The problem is it's been moved to a place where it has no windows. Now, of course, that would never happen in reality, would it? But we all know it does. Okay? And the reason that happens is that we're all operating off different bits of data. If that's fully integrated into one model, it can't happen. Okay? So just by doing this simple exercise, we've seen that this room was intended to be naturally ventilated. Now it can't be. Wherever the architect moves that space, all of its properties go with it. Okay? So we can very quickly change the properties of that space within our BIM software to mechanically ventilated. And then re-export that back to the Excel schedule. Well, so what, you may say? That shows a bit of a neat exchange. Yes, it saves us as designers a bit of time, because changing that on a 2D drawing previously would have taken us a long time. And you might say, probably doesn't add a great deal of value. But what it can also do now is inform the project cost consultant that there is more square meterage that is going to have to be mechanically ventilated or comfort cooled. So you're getting a better level of data into your cost planning, your very early stage cost planning, okay, which is really important. So just to illustrate, we take data from all systems and can apply them to spaces. So whether it's lighting control, what type of lighting control you have, what level of CCTV coverage, what level of access control. This little diagram here at the bottom. We have different access levels in the building. Green is very open access. Red is highly restricted access. We can look at the flows of those to make sure that those systems are as efficient as they can be. Linkages to analysis at the moment in BIM are actually quite clunky, which is disappointing because it's one of the first advantages that people tend to pick up. But what we can do on that bottom plan there, which shows some red rooms, that's using an export from an analysis package to show that those particular rooms currently have an overheating problem. So looking at the data in this way enables us to assess, well, why are those particular group of rooms having that problem? And in this case, it was to do with solar gain. We can also look through the embedded analysis within the software package, duct velocities, for example, and we can colour up ducts according to the velocity of the air in them to see whether we have any particular problems with acoustics. So green is good, red is bad. Okay? And just as a little illustration of that, again, I have a little mover here. And the importance of this is, not only is this useful for us in design, but I think it will give you a benefit as building users to look at change of use of space. And you don't have to be an expert in the use of this software to do this. This isn't a difficult thing. This is probably a day's training to be able to do this. So if you have a change of use of space, for example, that requires you to introduce more air, you can do that simply by clicking on the diffusers on those plans, applying an additional airflow to them, and the software will assess whether the current system can cope with that additional air. So I'll just run this animation through to its next stage. So we just, and I apologise it's not clear, we're just applying a bit of an additional flow to those diffusers, and if I pause it there, the system has calculated that not only have your branches turned red, which you might expect to be the case because they're getting a lot more air through them, but look, the route back to the riser has also turned orange. Now you might not expect that to be the case, but that's indicating that you need to look at the sizing of those ducts. So you want to change the use of that space, you have to look at some work outside of that space further down the line. Then we can very quickly click on that route, say we want to limit the flow within those ducts to, say, 4 meters per second, and the BIM software will automatically resize that duct run for us. Okay? Really, really useful for us as designers, because it makes us very efficient, which ultimately reduces cost, but also useful to you, I hope, in terms of looking at impact of change, which in education, as we know, you're probably one of the biggest, it's probably one of the biggest things that you have to deal with on a day-to-day basis. Simple things like quality of drawing output and clarity of that is made so much simpler, because for every system we can apply a colour, which will identify it not only in the model within that colour but on the drawing. So you can very clearly see what systems go where. Okay? A very, very simple thing, but hopefully really, really useful, not only to the contractor but to the end user. And as I said, that goes right the way through to the model. These are just some simple model shots, and as you can see, those containment and duct routes are coloured the same. So one will be return air, one will be supply air, etc., etc. And of course, what the software can also do for us is allow us to look at clashes. So again, I don't want to make promises here, but this is really enabling us to focus in and iron out problems before we get to site. And there's lots of data becoming available in the industry now to demonstrate that this is actually the case. The number of RFIs we've had on this particular project have been minimal from site, which is really, really encouraging. You know, in the ones and twos rather than the tens to hundreds that we might expect on a project of this size. And it's all about getting that coordination absolutely right before we start to build. And coordination, I mean, this is an example of lighting. In a traditional 2D world, we would have had a number of 2D plans showing those lights in the atrium. And probably no one would have picked up that the view of those lights from the atrium don't line up until it was on site, actually, because it's a very difficult thing to do when you're looking at a 2D layered plan of each level. In the 3D model, of course, it's easy, it's apparent, so we can correct those problems as well. So just a little view of the BCU model here, with it's in its current state. And what I wouldn't want to say this is a visualization, because it's much, much more than that. You can click on each component of this model and it will tell you the properties of that particular component. And I'll give you some examples of that in a moment. But just from a visual perspective for the time being, there is a value, I think, in using these techniques to very, very clearly state to all of your multitude of stakeholders that you have exactly what you're going to get. Okay? So it's a good way of communicating design, managing expectation, okay, to ensure that all of your stakeholders are happy at last. So I'll just run this through. It's very quick. And this level of kind of visualization, it's already starting to have some unusual applications. For example, the building control officers couldn't quite believe we'd gone to this level of detail. And you see, in terms of showing exit signs, he actually said to us, well, can you give me the model? Because I can then just virtually go through the building and check you have all of your exit signs in appropriate places. Okay, something perhaps we hadn't thought of before, but very, very useful techniques. So BIM gives us the opportunity to review what we do and how we do it. Just a few other examples here. And I must emphasize, this is all drawn from the same model. So there's three very different ways of conveying this data. There's a 3D visualization, there's a traditional plan that your contractor would use with all of the circuiting data on, and there is the circuit chart, okay, the distribution board schedule. All these can be produced automatically and can be drawn straight from the model. So the consistency of data between those levels is absolutely accurate. And this allows us to do things we've never done before. There's a BREEAM credit, which asks us to calculate the amount of volume of insulation on pipework in a building. Used to be an incredibly laborious task to do in a 2D world. But because our models now know all of the pipe sizes and all of the pipe run lengths, it's very, very simple. This is literally a 5-minute task to calculate the insulation volume. So where can we apply these techniques? Lighting loads for energy analysis. We used to work off assumed values. Now we can run off schedules in a matter of minutes, which gives us actual values for all of those lighting loads. And I'm sure applications of use of these techniques, linking energy use to occupancy, time data if you like, currently is a bit of an untested area, but the scope has to be huge. This is the final animation I have for you, which basically illustrates, again, a number of different ways of producing, oh, that's not good. It's only mine that's gone off. That's okay. No, it doesn't look like that one's going to run, unfortunately, and it's done for my screen here. There we go. Just give it one more try. What this intended to show you, really, is, again, a number of different ways of representing a lighting layout. But what you can do is click on one of those luminaires. It will tell you exactly what the lamp type is. It will tell you what the lamp replacement cycle is. It will tell you what the control gear is. It will give you the manufacturer's reference. It will give you all the part numbers. Now, taking that data and putting it into an FM package to give you FM cycles for different bits of kit, obviously is very, very simple to do. And again, it's giving us big benefits on things that perhaps we didn't envisage at the time, like safety. So you'll see there that there's in a lecture theatre, we've put a cone, a hazard cone within the space. That means there's a particular hazard that the people working in that space need to be aware of. So if they click on that cone, it'll say, you're working in a space where you need to get to a particular thing that's at high level. This is the means that you should use to access that equipment safely. It's a lot better, I hope you agree, than us delivering an A4 booklet of hazards that, of course, you all read and get aware of when we hand over a facility to you. It's all there in the model. It really helps. And the illustration here on the right-hand side again, one of Fred's colleagues had a bit of a doubt as to whether we could get the transformer out of the substation. So we used the model data to prove that actually, yes, there's a very usable maintenance zone to get that transformer out of the building. And then, of course, there's lots of linkages through to things like programming. Okay? So we embed objects in a model. You could apply an installation time or whatever to all of those objects and draw out an installation schedule, etc. We can help the QSs, as I've also said, by running off early stage data of square meterage areas of particular types of treatment or whatever. And in the latter stages, give them absolutely up-to-date quantity information. So you can see here, we know that in Fred's new building, there's 5,921 luminaires. But looking through to fabrication and installation, again, there's massive benefits to be made. Because what we're doing now is working in a very integrated way with contractors to basically eliminate that reworking cycle. And what we're finding is contractors are asking us to do much, much more detail and to develop our designs very much more with fabrication in mind. And they are using these techniques not only to brief their guys on site. So this sort of stuff is starting to become fairly commonplace now. You will see teams of labour teams using models on site to look at areas that they're going to be working in that day before they go and do the work. This is commonplace in the United States. They've been doing this for some years. It's less so here. A lot of contractors will claim they do this, but actual application of it is still a little bit patchy. And then taking that out to setting out on site, our models can be used to laser pinpoint fixing points, etc., on construction sites. Not universally done yet, but I certainly think it's only just around the corner. And this is an interesting one, again, from a contractor friend of ours in the States. They now have their modelling, and they have such confidence in their modelling, that what they do to generate their as-fitted record drawings is they laser scan the room after the installation is complete and before the ceilings go up, and then just overlay their BIM model. And surprise, surprise, they are nearly always absolutely aligned. And when they're not aligned, they just have to do a few tweaks in the model to get them aligned. So the level of accuracy of that record information is absolutely first class. And by the way, I don't know if any of you have used this kind of laser scanning technology, but for me personally it's becoming so cost effective now. I would be very nervous about doing any refurb job without getting that sort of scan done first, because it absolutely provides us with first-class information and helps iron out potential difficulties on refurbishment projects in particular further down the line. So facilities management, and this is where I think we have still the biggest leap to make. There are packages available, and we're going to be using them with Birmingham City University, that will draw all of that model data together, it will draw all the installation data together, and hopefully present it to Fred and his colleagues in a usable way. Things like having barcodes on door jambs of spaces that can be scanned, can instantly take you to that area of the model and give you all the data about that space. Okay, down to that level. But I still think there is some way to go here. And actually what we need to do is work closely with guys like yourselves to understand what this software can do, and to understand ideally how you need things configured and what information you need out of those models. And for me at the moment that still is perhaps the missing link. So I hope that gives you a good summary of where we are as Arup, and obviously a number of other companies are. We're all kind of at a similar kind of level. And hopefully gives you an insight perhaps sufficient to perhaps scratch beneath the surface of people that come to you and claim that, yes, we do BIM. And as I said earlier, it always should start with the question, well, what do you mean by BIM? And what do you actually do? The barriers to progression, we're a construction industry are relatively resistant to change, and all of these barriers have been thrown up over the last 2 to 3 years as we've been on this journey. First of all, people say, well, have we got the skills? Have we got the technology? Is the software mature enough to apply these techniques? Do our clients really want it? Do our clients really want BIM? What about the contractual setup? Are your designers prepared to hand over their precious 3D model of a space? Is quite an interesting and tricky issue. Our lawyers are actually quite nervous about that, but from my point of view, if we don't hand over those models, what's the point? So we do have a very free and open policy in terms of accessing our models. So I think we've tackled most of these. I think most of these barriers are now, there is a solution to drive through most of them. I'll add an extra one on the bottom, which I think is probably the biggest barrier still, which is the fear of change. But what we need there, I think, is some inspired clients to give us the inspiration to make that change. And undoubtedly we are already seeing that it gets realised as benefits on projects which I have no doubt will contribute massively to the kind of savings that UK government are looking for in construction. And on that theme, I'll just finish with a quote from a guy that hopefully you know. It is hard work. It does require effort. At Arup, we have a policy of investing 2.5% of our turnover every year in research and development, and a lot of that has been channelled into BIM. We're only now starting to see the benefits, and the benefits are reduced costs, freeing up time, and a much, much higher quality and quality assured product. Okay, so on that, I'm happy to take any questions, Fred, that anyone may have. Or
do you have any problems with the model becoming too large to be, does it become unwieldy?
Oh, I think you know something about this. On the Birmingham City University project, no, I can honestly say it wasn't a problem. We originally started out with trying to decide how we configured the model, if you remember, and we had some advice from a BIM consultant, Beware, that we should split up the model in, I think, to 4 parts, each floor, system by system, etc., which would have created something like 70 different models. Well, we said, we don't think that's going to work. And what we actually ended up doing was having an architecture model, a structural model, and an M&E model that we brought together every 2 weeks. Okay? And we use that then to do coordination activity. The models got relatively large. Our M&E module was, I'm trying to remember, about 80 megabytes. But it never got to the point where it was unusable or it was slowing the guys down. Now, there will come a point, I guess, inevitably when that happens. Where we have had problems with model size, on a car plant we're doing at the moment, where we are architects, structural engineers and M&E engineers, we've tried to work with all disciplines in one model live all the time, and that has given us problems. There's no two ways about it. So you need to be a little bit careful about how you set these things up. But on your particular project, I don't think that's been an issue at all, which has been great.
In terms of all the boxes of each element, are they being provided by the manufacturer, or you have to put every element in?
Really good question. Depressingly, no, they're not provided by the manufacturer. It's getting better, but on that particular project, we had to embed all of that data, and we're still having to. Now, part of that is useful to us, because actually what we can do is with each object we can include the specification data, and all this is retained with the object. So you guys know when you get the build, you know what we've specified. The contractor can put what he's installed, and we can look at any differences very easily, etc., etc., and hand that over to you as one package. So what we're currently doing at the moment is going through and embedding our specification requirements on all of those plant objects. But the problems the contractors face, in particular at the moment, is that that data is only just starting to emerge from manufacturers, and it's a bit clunky. What most manufacturers are doing at the moment is giving you a fully engineered model of, say, a light fitting, which looks absolutely like the light fitting. If we embedded that in our models, they would get massively over large and would be unworkable. So we have to be quite specific about what we want from manufacturers, I think, and that's kind of the next step. We need a stripped down version which looks a bit like the fitting, but has all of that lovely data associated with it, part numbers, lamp types, etc., etc. So they're being a little bit slow coming to the table at the moment, but that has to get fixed over the next year or two, doesn't it, I think?
Can you put engineering to an existing building that's going to be refurbished?
There's no reason why you can't. I'd just say you need to look at what benefit that is really going to bring to you, I suppose, would be my warning. If you're doing a substantial refurbishment, I think the technology of laser scanning, and we can now develop BIM models within Revit direct from laser scans, I think you would very quickly be able to build up a model of an existing building that's going to have some other kind of major refurbishment. What I would guard against is probably going out and trying to put all of your estate into BIM models, because it would be quite a costly exercise to do that, and I suspect it might not deliver.
I'm thinking of the newer buildings where,
yeah.
But saying that, I know one building built in 2004, and every single one's been refurbished because of changes in research. And we could find out some of the stuff we've done 2 years ago, in 3 years' time, we come along and say, we want to change our research, replace it.
Yeah. Well,
I'm thinking about some buildings are never going to change, but other buildings are going to change. Do change regularly.
And I think in that context it could be quite useful. And I think what it also does is it means that if you had a model of that building that was changing all the time, you have very good data to hand on to your next set of designers. Okay, it would save them every time going back and trying to dig out all of this information. Because it really is hard to find that information. Surprisingly hard.
If you apply this, say, as a logbook exercise,
Yeah.
and one of the problems we get, I think what people find, who ends up doing the logbook? You know,
Yeah.
what kind of cost would it potentially be, for the building?
For doing the logbook?
Well, for doing this as a logbook exercise.
In terms of doing this, if we're starting with a new build, well, I am still being filmed, so I need to be a bit careful. But I think you should be expecting this kind of stuff to be delivered by designers for no extra cost. And I think in time, you should be expecting it to be delivered for less cost. Certainly in terms of, perhaps I should clarify when I say designers, in terms of that overall design and construct activity, there are bound to be net savings out of the process. In terms of the issue you raise about logbooks and so on and so forth and who does them, I think because as designers we're now being asked to do generally much more design, I think it's more sense for us to do that activity than it is perhaps as it traditionally would fall on the contractor to do. And we can tailor what data you see that we embed within the model to give you what you need in terms of operation of the building. An example that we're looking at with some custodial clients is looking at how we can use the model of the buildings that we develop to do scenario planning. So looking at different emergency situations, we can use these models, for example, to give us information about pedestrian flow in a fire situation or in a custodial environment. Okay, what do we do if something kicks off in this part of the building? Can we use that model to train our staff? Can they navigate through that model? So there's a whole host of different applications that you could use this for.
Where does the design risk lie in this report in debating the design costs?
There's no one answer to that, really. I think part of to get that efficient process I was talking about, and to avoid this reworking of design around the interface between design and construction, there are basically two ways you can go. Either your direct employed consultants do less and you let the contractor take over earlier with their own in-house capability, or you go through a novation route, or you get your designers to do much more design. Okay? What we're finding at the moment is the most popular route, and probably 70% of my current workload in my group is direct for contractors, is we're finding the novation route very popular. Okay? Because I think clients see that as keeping their hands on the reins of quality, but delivering a good value design and build solution. Okay? Now what contractors like about us doing more detail is that design responsibility line is then very clear for them, because it sits with the designer. In the old world where we used to do detailed design drawings and the contractor used to take those and rework them, that design liability is much more blurred, because what they actually had to do is change routes to get the coordination right. So then they had to go back and redo recalculation of the design to check it was still going to perform. So that put a responsibility on them for design, which clearly they really, ideally, would not want to carry. So I think this has the potential to make that design liability line much clearer for certain types of procurement route. I hope that.
Stage did you take the design up to with the project work with Birmingham City?
We took it to stage E under the direct employment of Birmingham City University. Then we were novated to NG Bailey, who were the M&E subcontractor, to complete the design. And the design that they got from us was very nearly, by default, almost a coordinated working drawing level of design, because it's very hard in a BIM world to deliver anything less. You know, you can't really deliver a drawing which shows distribution routes but not coordinated, because in a 3D model that would look stupid. It has to be coordinated. So I think NG Bailey's opened NG Bailey's eyes to perhaps a slightly higher level of deliverable from their designers, which they are reaping the benefits of now, hopefully, in terms of a lot less problems on site.
Sorry, Dan, that's a question about from a university side. When schemes are handed over to,
Yep.
and then BIM models handed over to the client, in terms of maintenance regimes and future projects, which obviously this tool is very useful for, do you find that the skill sets and the resources on the client side perhaps don't match the full potential of what your experience is on that?
My experience of it is not great at the moment, because I think we're still at the point where we're only getting on proper BIM projects to that point of transition. And it is a big issue, obviously, because with the amount of churn that you guys have to deal with, I think there's big benefit in you having some BIM, in this case Revit, skills to enable you to take those models, interrogate them, and perhaps do a little bit of amendment. But certainly to have that Revit model available for you to pass on to your next set of designers who might be refurbishing a quarter or half of the building. So yes, I think there are some training skills that are required to get to that level of usage, but I don't think it's a huge hurdle. I'll tell you now, you're always a bit worried about this because there's always cost associated with any change. And the real cost to us has been in training up our technician workforce. They're now back to what you might call an engineering draftsman that we had about 20 or 30 years ago. So they're guys that understand the systems and understand how to coordinate systems. The way we work now, my engineers pretty much work through the early stages of design direct in Revit. They don't need any technician input, and the amount of training they've had to do that is about a day, and then it's applying yourself on projects. So it's not a great deal of training. So yes, I think some training is needed, but I don't see it as a massive hurdle.
I wanted to ask about different platforms. How many are there, and what has the government said in terms of platforms by 2016?
The government said nothing really about platforms by 2016. What the government are working on at the moment is trying to standardise the pro forma, if you like, of information that's available at the end of a project. And it's used, you might have heard the term COBE, which is basically a huge Excel spreadsheet which tells you about every component on the building. Okay, so that's what they're putting their effort into. They can't really say, can they, our government strategy is to use Autodesk Revit, because that would just kill all the competition. And there are, we use Revit, but there are alternative packages, and there's lots of alternative packages that are very mature for structural engineering and architecture. ArchiCAD, for example, Tekla for structures, so it's quite open. In the M&E world, I think your choices are very much more limited. It is pretty much Revit, MEP. And I just hope that the competition will be stimulated to make sure that there is an alternative available, because I think that's a very healthy situation. I wouldn't really want to hand everything on a plate to one particular software provider, because then they'd be able to hold us all to ransom, wouldn't they, forevermore. So I think deliberately the government are keeping it open. But on their projects, what they're saying is you need to deliver this COBE format, which can be interrogated through Excel. So they're saying every project that we have in the government will be handed over in this form, and they are developing how they then use that format of data moving forward.
Can I just ask one, Daniel, about value engineering and building modelling, giving, for decision making? For the ongoing life cycle cost of the building?
Yes, yeah, sure. There was a movie on there that didn't quite run, which was a shame, which showed on Heathrow Terminal 5, which, yeah, it's quite an old project now. We actually used our BIM models to compare two different structural principles and see how they're built up over time to identify what the difference in the capital cost of the build would be, and taking into account of things like speed of construction and early handover. So those techniques are definitely there and are used, but beware of people that say they are widespread. In terms of looking at maintenance cycles and using the models to influence design decisions early on, I think that's a bit more difficult because there's a bit of a time lag there in the data, and I think people genuinely haven't thought about that level hard enough yet. And this is where I say that for me, most work over the next few months, years, needs to be put into that transition between construction and FM, defining what FM managers want, need, what data is useful to them, and working out how we can provide that data, and again, get that essential feedback loop back into design. I think all the facilities are there. So the tools we have at the moment, a bit like a box of tricks that can do anything, we've just got to work out what we want them to do. And I'm afraid that process takes time. No more hands. There you go, Fred. Okay.
Dan, thank you very much for an interesting and informative session. I'm sure all the guys and ladies here enjoyed it and will take something away from this. And on behalf of the association, I'd like to present you with this token of appreciation.
Oh, thank you very much.
Thank you very much.
Thank you. Thank you.